Welcome to This Explainer. Today, we are unraveling the incredible story of a massive, completely forgotten landmass. A landmass that honestly shaped both human and natural history in ways you probably wouldn't believe. And to find it, we're not going to be relying on modern satellite imagery or anything like that. Instead, we're going to unravel a really fascinating 19th century geographical mystery that eventually leads us straight to a sunken world. So, let's get right to it.
Okay, here's the puzzle that started the whole thing. Why are there no tigers in Australia? I mean, it sounds like a super simple, almost childlike question, right? But back in the 1860s, there was this brilliant British naturalist named Alfred Russel Wallace. He was out exploring the Indonesian archipelago, and he stumbled upon this exact, massive biological mystery.
So let's dive into this. Wallace noticed something incredibly strange. On the island of Bali, the wildlife looked pretty much exactly like mainland Asia. We're talking elephants, tigers, rhinos, mammals that give live birth. But if you just hop on over to the neighboring island of Lombok, which is a mere 12 miles of ocean away, practically next door, everything completely changes. Suddenly, you're looking at kangaroos, egg-laying mammals known as monotremes, and marsupials. It just didn't make sense. How could the animals be so radically different across such a tiny stretch of water?
Well, Wallace identified this invisible boundary, which we actually call the Wallace Line today. And what he theorized, which modern geology totally backed up later on, is that the narrow Lombok Strait actually hides a tremendously deep oceanic trench. So even when sea levels fluctuated massively in the past, this specific trench stayed flooded. You add in these incredibly powerful ocean currents sweeping through there, and that tiny 12-mile strait acted as a literal, impassable barrier between two completely different biological worlds. You had Asia to the west, and to the east, well, a totally different landmass altogether.
Section 1. Welcome to Sahul, the Pleistocene Ice Age.
Now, to really understand Sahul, we have to wrap our heads around the staggering scale of the Pleistocene era. Global sea levels didn't just drop a few feet. They absolutely plummeted. We're talking drops of up to 120 meters. To put that into perspective, that's roughly the equivalent of a 30-story building. Because of this massive drop in sea level, vast continental shelves that are completely submerged today were fully exposed. It revealed this colossal contiguous supercontinent that we now call Sahul. So instead of the separate islands we know today, Australia, New Guinea, and Tasmania were actually all connected as one massive expanse of dry land. And it wasn't just a single boring environment either. It featured an incredibly varied geography, everything from thick, humid rainforests up in the north, all the way to wide grasslands and dry inland deserts.
Section 2. Australia's Giants, Megafauna of Sahul.
And this brilliantly illustrates just how wild things got. Let's shift our focus to the bizarre, isolated megafauna that evolved across this newly revealed supercontinent, completely cut off from the rest of the world. Sahul was, quite literally, a land of giants. I mean, just picture this cast of creatures. We had the Diprotodon optaton, which was a giant 3-ton marsupial roughly the size of a modern rhino. There was the Thylacoleo carnifex, a terrifying 150-kilogram marsupial lion with massive incisors acting as an apex predator. Oh, and we definitely can't forget Megalania, this giant predator lizard related to the Komodo dragon. Then you've got Genyornis newtoni, a towering 300-kilogram flightless bird, and Pelorchestes azael, a massive marsupial tapir with these huge claws for tearing down high branches. It just completely flips our understanding of apex predators on its head. In this lost ecosystem, reptiles and marsupials absolutely ruled, rather than placental mammals like those tigers over in Asia. But then, they vanished. Just gone. And dating this extinction is actually incredibly tricky, mostly because it happens right at the absolute limit of where carbon dating is reliable. So paleontologists have to use these ingenious proxies to figure out exactly when the ecosystem collapsed. At sites like Devil's Lair and Lynch's Crater, researchers track something called sporomelia. It's a fungus that only grows on the dung of large herbivores. And around 40,000 to 50,000 years ago, the concentration of these dung spores in the sediment suddenly just plummets. Right at the exact same time, those massive fossilized eggshells found across the continent abruptly disappear from the geological record entirely. So this gives us a really strong indicator of a sudden, dramatic extinction event.
Section 3. Human Explorers, the First Arrivals. Now, right around the time this landscape was populated by all those giants we just talked about, a totally new species arrived to shape the continent's history.
About 65,000 years ago, the very first maritime explorers successfully navigated their way from Wallacea, which is modern-day Indonesia, into Sahul. These early indigenous ancestors likely crossed over temporary island land bridges and made short sea crossings to arrive on this vast area known as the Northwest Shelf. Obviously today, this entire area is totally underwater. But back then, it formed a massive, dry, contiguous landmass that connected the Kimberley and Arnhem Land. So the absolutely crucial point here is just how habitable this lost landscape truly was. Recent demographic modeling reveals that this now sunken Northwest Shelf was basically a massive oasis. It featured a huge inland sea right next to a massive freshwater lake, all encircled by these high escarpments cut by deep gorges. At its absolute peak, which was around the height of the last ice age, roughly 20,000 years ago, researchers actually estimate this single stretch of exposed continental shelf could have supported a staggering population of up to 500,000 people. No way, right? 500,000.
Section 4, Sinking Atlantis, End of the Pleistocene. But, the Ice Age couldn't last forever. Let's walk through the timeline of how this played out to see the catastrophic end of this epoch, which completely reshaped the entire continent. So the first humans arrive in Sahul around 65,000 years ago. By 50,000 to 40,000 years ago, we see that sudden megafauna extinction we discussed earlier. But the real geographic shock, that comes later. Starting around 14,500 years ago, an event known as Meltwater Pulse 1A triggers rapid global sea level rises. Incredibly, within the span of a single human lifespan, roughly 50% of that massive Northwest Shelf was completely drowned. The rising waters eventually cut off Tasmania from the mainland around 10,000 years ago, and then separated New Guinea roughly 8,000 years ago. As you can probably guess, there was a tremendous human cost to this localized Atlantis event. As the sea levels rapidly rose, populations were forced to retreat inland just to stay ahead of the encroaching coastlines. And the crazy thing is, we can actually see the permanent record of this mass migration today. Archaeologists note sudden peaks of occupational intensity at sites across the Kimberley and Arnhem Land during this exact period, and it's accompanied by a sudden explosion of incredibly distinctive new rock art styles. These displaced people literally brought their stories, their culture, and their lives with them as their map rapidly shrank. I want to leave you with this really powerful thought from lead researcher Cassine Norman. The temptation to overlook the continental shelf margins of late Pleistocene Sahul in discussions of early peopling and expansion risks oversimplification and misunderstanding of this pivotal period in history. It truly makes you wonder, doesn't it? As we walk along the coastlines of the world today, how much of our shared human history and the long-lost secrets of the natural world still lie hidden right beneath the waves at the bottom of the ocean?